Okay, Chapter 6 Review. So we're going to start with Question 2, since Question 1 is just definitions. So Question 2 gives you figures of the pattern represent the first 4 triangular numbers. So for A, they've asked you to copy and complete the table of values for the first 8 triangular numbers. So, we want to copy the table. So I'm going to call figures F and triangular number Tn. So we're going to do to 8. So for 1, we have, these are the numbers that are given. So 1, 4, 9, and 16. So when looking for a pattern here, you notice that 1 squared is 1, 2 squared is 4, 3 squared is 9, and so on. So to continue the table, 5 squared is 25, 6 squared is 36, 7 squared is 49, and 8 squared is 64. So that's part A. Part B is asking you to graph the data and sketch the line or curve of best fit. So I don't have a graphing calculator, but for part B, it would look something like this, with this being figures and this being triangular numbers. So the triangular numbers are increasing faster than the figure numbers are. Question 3. So the table shows the temperature in degrees Fahrenheit measured inside a greenhouse each hour. So then you have your table, and they're asking you to graph the data. So again, they're wanting you to do this on a graphing calculator. So given that I don't have one of those, a rough sketch would be something like this. Although it would not cross the x-axis because they're remain positive. So it goes along the lines of that. Starting at 57, having the highest point at 101, and ending over here at 12. So that's what your graph would roughly look like. So for part B, they're asking you to find the equation of the curve, which you just plug the calculator and find the answer, which you would get to be y is equal to negative 1.11x squared plus 13.61x plus 56.16. So that's what you get. But again, they're looking for you to use a graphing calculator. You're not going to have to be able to come up with this equation on your own. Question 4. So graph the quadratic relation y equals 2x squared plus 4x minus 1 using a graphing calculator and sketch the graph in your notebook. So again, without my graphing calculator, it would look something like something along the lines of that. Yeah. So part A, identify the coordinates of the vertex. So that would be the value here. Part B is write the equation of the axis of symmetry. So that would be x equals, and then whatever this number is. So x equals my blue line, essentially. Because it's an x value, it's infinite y values. C is identify the y-intercept, which would be this guy here. D is identify the maximum or minimum value. So this one's going to have a minimum, and it would be this value. They're looking for the y value that goes across here. So your minimum value and your axis of symmetry form the coordinates of your vertex. And then for E, they want you to identify the x-intercepts, which would be these guys. Question 5. So an archer shoots an arrow at a target 20 meters away. The following data shows the height of the arrow above the ground at various times it was shot. So then you have your table of values. A is plot the data on grid paper, placing the time on the x-axis and height on the y. So, again, not having a graphing calculator, it would look something along the lines of this. So, B is draw the line or curve of best fit, which is essentially what I've drawn. Originally, you would have only had points, so just make them look like a curve. For C, what is the shape? This is called a parabola. That's important to know. D, if the arrow hit the target at 3.5 seconds, so at the end of the values that they've given you. How far had it gone after 2 seconds? So they want to know the distance after 2 seconds and after 3 seconds. So here, so we want to find the speed. So if we know how fast the arrow is going, then we can figure out what distance it is at the various points. So speed is distance divided by time. So the distance is 20 meters because that's how far away the target is. And that took 3.5 seconds. So that means the arrow is traveling 5.71 meters per second. So if that's every second, then that means in 2 seconds, if we multiply that by 2, we'll get the distance. So it's going to be 11.42 meters. Again, we've just doubled this because this is in 1 second. So similarly, for 3 seconds, we're going to multiply it by 3. And we'll get 17.13 meters. And how did you find out? We found out by finding the speed of the arrow and then using that information to then find the distance. Okay, question 6. In the cross-section of a large tree, concentric circles form around the center. Each ring represents 1 year of growth. One particular tree increased its radius approximately by ½ centimeter with each new ring. So draw a graph comparing the age of the tree to the number of rings. So, the graph would, so if this is age and this is number of rings, it would look something like this. Because every year we're adding 1 new ring. So it's going to be a steady increase. So this is linear, which is part B. And it's, again, linear because it's going to have the same slope the whole way along. We're increasing by a year and by 1 ring each time. For C, do you think the graph comparing the number of rings to the age of the tree would be linear, quadratic, or neither? So again, it would be linear because it's kind of the same thing as here. It goes the other way, so If you had reversed it, it would still be a linear relationship. Again, because of the same slope. So for D, if the radius increased by half a centimeter each year, by how much did the circumference increase each year? So D, so circumference is equal to 2 pi r. So 2 pi half, which when you plug it into your calculator gives 3.14. So it would increase by pi essentially each year. E. Can you tell how old a tree is by measuring the circumference of the trunk? So theoretically, yes. Using part D here. So with the circumference, you could be able to figure it out. However, the rings are not equally spaced. They become closer together, farther apart, depending on the climate. So it's not going to be a consistent half centimeter all the time, but you could, theoretically, it would work. Okay, question 7. So the shape of the roof of a movie theater is represented by the equation h equals negative 0.08 d squared plus 3.15, where h is the height in meters of the roof from the top of the walls and d is the width in in meters, from the center of the roof to the walls. So for A, create a table of values with x from -5 to 5. Okay, so x is the same thing as d in this equation, so I'm just going to switch it out. And then y is the same thing as h. And they're asking us to find all the y values, which you do by plugging in the values for d, and it will spit out the answers for h. So you get 1.15, 1.87, 2.43, 2.83, 3.07, 3.15, 3.07, 2.83, 2.43, 1.87, and 1.15. So that's what A gets you. For B, find the first and second differences. So now we're going to extend this. Okay, so first differences. So you subtract your h values, which will give you 0.72, and I'll alternate so you can see. Then these guys will give you 0.56, 0.4, 0.24, 0.08, negative 0.08, negative 0.24, negative 0.4, negative 0.56, and the last one is negative 0.72. One thing to note here is you're always going this number minus the one above it. So for the pair after that, it'd be this one minus this one to give you this. And to get 0.4, it's this guy minus this guy. It's always the bottom one minus the top one. Okay, so then to find second differences, again, bottom one minus the top one. So these two, and you get negative 0.16. So that's this minus this. And the next one, 0.16. And it will be the same the whole way down. You are expected to be able to fill this in completely and not just do an arrow, but I'm not going to keep writing out negative 0.16. So part C, based on the second differences, what shape is the roof? So when the second differences are the same, we know it's a parabola. You could also graph the original values, but that's not always convenient. So second differences, if they're all the same, tells you it's a parabola. So then D is verify your conclusion by graphing the equation using a graphing calculator. And I don't have a graphing calculator, so either you can put it on a graphing calculator or graph it by hand, or trust me that it will be a parabola.